Good morning, everyone. Sorry for the delay. We were just waiting for everyone to join. Just going to mute Gary here for a while. Welcome, everyone. Thank you for joining us in today's webinar. My name is Jad Abiali, and I'm the Strategic Communications Partner for Middle East and Africa at Guardian Glass. Guardian Glass is one of the world's leading providers of architectural and residential glass solutions. Today, we are presenting the new Guardian Select Fabricator program, presented by Gary Prideaux, the Middle East and Africa's Regional Manager for the Technical Assistance Center. Gary is leading a team of technical support engineers from 3 sites, Saudi, UAE, and Egypt, with 38 plus years of experience in the glass industry, of which 22 are in the Middle East. Gary delivers an immeasurable wealth of knowledge and experience in all aspects of glass processing, PVC, window manufacturing, and aluminium. Gary is also joined by Maher Hassoun, the Sales and Operation Leader for Africa and Middle East, who will also be happy to answer your questions as well on the webinar. If you have questions during the presentation, please type them into the question box in your control panel on the right side of the screen. I'll bring them up at the end of the presentation, where we will do our best to answer them. Please note that the webinar today is recorded. Therefore, if you would like to ask questions at the end and prefer to remain anonymous, you can check the anonymous checkbox provided at the Q&A window. Moreover, you will be notified via email when the webinar is published live on YouTube, with a link to watch it again at your own leisure. Now we will turn over the time to Gary Prideaux, who will introduce himself, and Maher Hassoun as well, to begin the webinar. Thank you. Over to Gary. Sorry, just a sec, Gary. You're muted. Yeah, you just need to unmute yourself.
Hello, good morning, everybody, and welcome to this SOQ Select Fabricator program. It gives me great pleasure to be able to present this to you today. This is a great achievement for myself and for Guardian, we will go through the presentation, which explains the program in detail. Thank you, and once again, thank you for joining.
Hello, good morning, everyone, and thanks very much for joining and this morning for this webinar to introduce the Select Fabricator program. My name is Maher Hassoun. I'm the Sales Operations Leader for Africa Middle East, and I'm really happy to join you in this. And I will take the opportunity to say Happy International Women's Day for all the ladies that are joining this webinar, as well as all the women in the world. And with this, thank you very much for joining. I'll turn it to Gary to start the webinar. Please feel free to type in your question, as Jad mentioned, and we'll be happy to answer them. Thank you very much.
Okay. I'm just trying to find my presenter view here.
Yeah, that's good.
Okay, yeah, I don't see my presenter view. Okay, I'll have to try and read it from the start. Okay, so thank you once again for joining. I'd like to, before I start with the presentation, I would like to start with the actual photograph that you can see on this slide here. This is the Marriott Concert Hall, which is based in Saudi Arabia, in the Al Ula region. This has now been awarded the Guinness World Record for the biggest mirror-clad building in the world. Okay, this is an architectural feat that is now being used for the Winter of Tantora festival in Saudi Arabia. Okay, so what I'd like to start now is with the Select Fabricator program. Today's agenda will be the Select Fabricator program, optical quality, architects, and technical services. So what we'll start is with the Select Fabricator program. In the past, we had a program that was basically more supportive to the glass processor. So we took an initiative to to decide how we can open this program to the wider audience, from architects all the way down to the glass processor, which includes the contractors and aluminium cladders as well. So we decided to come up with this program, which we'll explain in the next few slides. Okay, the optical quality section will be basically for how the glass processing stage can have an impact on optical quality, and how the program minimizes optical quality to a very minimum. Then we'll move on to the architect section, where how we will explain in depth on how we will start from the start of the design of the project through to the glass being supplied at the end of the project. And then to the end of it, we will have the technical services section, where we will explain to you in detail all our technical services that will support the program and the supply chain for the project. So we have a new 3-tier program. Okay, first, the lowest part of the program is the Select Limited tier. Now, this is basically the tier where processors who wish to start and become part of the new Select Fabricator program, this is the start, basically the start level. So here we have a limited supply, so a limited products range, which will be just basically our SunGuard HD, HD Plus, Solar, and Neutral 70. And then we have the Select Advantage. Now, the Select Advantage is actually the current program. It's the old program. Okay, this program is there's no actual changes to this program, but we just basically renamed this. This is where all our current certified clients will automatically qualify for Select Advantage. And then we can move on to the Select Elite. This is the main focus of today's discussion. The Select Elite is the highest level of the 3-tier program, where we can differentiate between the glass processors basically on their capabilities, on equipment capabilities and a level of quality. The purpose of the new program, basically, and the main advantages are to improve the capabilities and overall perception of AME source fabrication. So this will basically identify the levels for the process in the Advantage and the levels for the people in the elite level as well. This will elevate our most capable customers as in the elite tier. Okay, and this will also include our marketing and how we will be able to market the Elite Fabricator into the program and once the project starts as well. To enable increased participation in projects work, this means that from the architect all the way through the contractor, through to the aluminium cladder and glass processor, this brings everybody together as one team, which includes our technical services, our marketing team, and our commercial team at Guardian as well. Okay. So the Select Advantage tier, the certification standards for Select fabricators remain the same. As I mentioned earlier, the current fabricators are automatically qualifying for the Select Advantage. The only difference with the Select Advantage now is that we will have agreed annual volumes. Obviously, we have a commercial side to the program now, so we will have agreed annual volumes for each processor. And the recertification frequencies will be 12 to 24 months. Now, we say 12 to 24 months based on the capability of the fabricator, how efficient they are at maintaining their quality records, maintenance records for the machinery, and so on. Now, for the Select Elite tier, this is the main focus, which carries the biggest changes in the program. So a key area of differentiation are certified capabilities and processing standards. For the Select Elite, they will be they will achieve more rigorous quality standards. Okay, very tighter standards. That's actually far better than the international standards. A new specification has been developed by Guardian, Select Optical Quality, that mirrors the elite fabrication quality requirements. So the new SOQ specification, which we'll talk about later in the program, explains in detail, based on whichever European standard or American standard the project is operating to. The tighter tolerances will be mentioned in that document, so we can discuss that further on in the presentation. The industry's most stringent low-E glass processing standards and most robust certification guidelines. So we've introduced this program, especially with the elites, that the certification program itself is very stringent and more robust. And this will only be basically a select few elite fabricators within Africa and Middle East will be available. So the select elite tier fabricator capabilities. So starting with pre-processing. So cutting, edging, CNC processing and washing. Everything from the start, from the storage warehouse all the way through the pre-processing sections of the processor will be monitored, and everything will be recorded in detail and presented to myself and my team upon request, should we ever require to support any program or any project. Heat treatment, which is probably the main focus of the Select program. Heat treatment is the section of the factory where the highest level of quality can be achieved. With the capability of the heat treatment, being able to produce glass to the highest level of optical quality is from this point with heat treatment. Heat soak testing is becoming more prominent in this market, in this region. So heat soak testing is a requirement for the elite tier fabricator. As more and more projects now stipulate that the glass will be heat soak tested. Automated IGU line including robotic sealing. Now we do ask that the IGU line robotic sealing is a vertical sealing station. Okay, this helps eliminate any concave effects of the glass of the double glazed units while it's being manufactured. Could be usually in the horizontal. If the units are sealing horizontally, then you can suffer concave effects from the double glazed units. So we always recommend that a vertical robotic sealing station is required. Screen printing and digital printing capabilities also is a requirement for the elite fabricator. More and more we're seeing more decorative designs and projects as architects release projects now with different aspects, aesthetics for their projects. Screen printing and digital printing is there now to support the program as well. PVB lamination, and I say PVB because we don't certify EVA. So PVB lamination is a requirement also for the elite tier. We also ask that they have the oversized capability up to possibly 6 meters by 3210. There are a number of processes that's capable of doing that, and as the projects start to demand larger glass sizes, then we need to be able to support that with the PVB lamination process. And automated line scanner, obviously this is for the quality control, and this will monitor the glass as it exits the furnace. This will monitor the glass for roller wave distortion, edge lift, leading edge and trailing edge requirements. And also, to some extent, the new systems now can also check for anisotropy as well. Okay, so all these, as you can see in there, these are actually select elite requirements. Optical quality, obviously, when we're talking about roller wave, if you compare the European standard EN 12150 or EN 1863. They asked for a maximum peak to valley measurement of 0.5 millimeter. Now, for the Select Elite Fabricator, we are looking to reduce that to a minimum of 0.076 peak to valley, or with the plus or minus 120 millidiopters from the automatic scanner. As you can see from there, we've actually reduced the roller wave quite dramatically from the actual international standard requirement. Overall bow, again, this is to be maintained by the Elite Fabricator. The international standard, again, for coated glass products stipulates across the 1 meter length, 4 millimeter on overall bow. We're actually reducing that down to about, as a requirement to 2.6 over a 1000 millimeter length. Edge lift, leading and trailing, obviously, this is something else that becomes more apparent. The international standard there stipulates 0.5. We're looking at reducing this to 0.20 millimeter. Okay, to reduce the effect of the leading edge and trailing edge distortions. Center kink, which is not basically mentioned in the standard, we've introduced. This is actually part of the program where, as the glass enters the furnace and the glass can bend, if it's colder on the top, the glass can bend and it forms like a dish inside the furnace as it rolls back and forth inside the furnace. This can cause what we call lensing effect or center kink. So part of the program also requires that we monitor and measure this as well. And anisotropy, as yet anisotropy, there is not a standard that stipulates the level of anisotropy in heat treated glass. We understand that there is a standard being under development at the moment, and we are waiting, hopefully, to receive that. Either I'm not sure it's going to be this year or maybe sometime next year. Now, this is a recommendation now for our elite fabricators to have anisotropy available, because in the future, once the standard is released, then obviously it will become a requirement. Now, normally for anisotropy, you normally see this with more thicker glasses, 8mm, 10 and 12, and laminated combinations. And also color monitoring. So this is becoming, again, apparent on some of the projects that I've experienced over the past couple of years, where color monitoring from panel to panel has been a requirement, and it's written into the design document. So part of the Elite Fabricator program is that they must have a spectrometer which can measure the color, the reflected color properties of the glass inside the factory during production, or on the glass as it's glazed at site, so they can measure from panel to panel. We are looking to maintain any difference in color between a maximum delta E of 3. Okay. The heat treatment process. So what we have here is a side view of a typical heat treatment tempering furnace or heat strengthening furnace. As you can see, that the area that's highlighted yellow and red, that's the furnace. Usually this has a temperature of over 600 degrees centigrade, around 650, I should say. This is where the glass, once it's finished, the cut size and the arrest edge work, and it's been cleaned efficiently, the glass will then be loaded into the onload and then into the furnace. For 6mm, the heating time is approximately 240 seconds, plus or minus 5 seconds. Now, as you can imagine, the glass, when it reaches its temperature of around 630 degrees, the glass starts to become soft. Once the glass is up to full temperature, then it will move into the quench section and the cooling section. As you can see on this chart, on this drawing here, that we have a quench section and a cooling section. Most modern tempering furnaces have this combined now, where they will have actually controlled fan speeds which will give you higher pressure at the quench section, and then it will slow down for the cooling section. Manufacturing process, visual appearance. Okay, so again, tempered glass, overall bow. If during the tempering process, if you have a cold side of the glass when it enters the furnace, the glass can bend inside the furnace. Okay, so if you have a different temperature from the bottom of the glass to the top of the glass, when the glass exits the furnace and enters the quench section, then this can cause what we call overall bow. Now this can be controlled inside the furnace, and it also can be controlled in the quench section as well. So the maximum allowed tolerances for uncoated flat glass, EN 572 stipulates 3 mm per meter for tempered glass. That's to EN 12150, and also for EN 1863, and for 3% of the measured distance. Roller waves, as I explained earlier, this is where the roller wave is imparted into the tempered glass during the heating process. So basically what happens here is the glass, as it oscillates inside the furnace, it picks up the pitch of the rollers. Okay, so you actually get a wave, a very slight surface wave on the glass, and can be seen sometimes when it's glazed at sight. Okay, this is basically caused by the softening point at the end of the heating time. Okay. The maximum allowed tolerances for uncoated glass is 0.3 mm for uncoated and 0.5 mm for coated. This is according to the EN 12150 and EN 1863 for heat strengthened. The way to measure roller wave is by a simple ruler which will measure the wave deformation from peak to valley, and is more apparent in the tempered and heat strengthened glasses. Glass which is passed horizontally through an oven may contain a very slight surface wave caused by contact with the rollers, as we mentioned earlier. Now there are some usual inspection systems available. The first and most simple way of inspecting the glass is with a zebra board. Okay, as you can see in this picture here, you can see that the lines are at a 45-degree angle on the end of the furnace, or at the side of the furnace, and you can see apparent roller wave distortion there. The most modern equipment at the moment is the online scanners. Okay, as you can see, we have the Light Sentry and the Glass Denial look here. These are the most popular systems available in the market at the moment, and these measure the reflected distortion of the glass by using a very complex system of cameras and sensors. Okay, the automatic scanners are a requirement for the elite fabricators. So all elite fabricators, when they do achieve elite, they must have this system installed and operational. Anisotropies. Okay, as I mentioned earlier, the anisotropy is more apparent in the thicker glasses. It can be seen easily in 6 mm glasses as well. Usually this is more apparent when you viewed at an angle under polarized light. Okay, as I said, there is development ongoing now for the standard to try and reduce this phenomena, as it's called. And as you can see in these pictures here, you can see the actual pattern of where the glass is actually quenched. So the actual patterns you can see, like it looks like a leopard spot. These are actually where there's more stresses apparent in the heat treated glass. And under polarized light, or if you wear polarized sunglasses, you can see this more this phenomena. So how do we try to reduce the items which I've just discussed earlier, especially when it comes to roller wave, overall bow, edge kink, center kink, and so on? Well, basically, we've developed Guardian have developed a select optical quality, which is the SOQ document. This is the 08800 document, which usually will be written into the design engineering documents at the release of the from the architect's office, or from the contractor's office. This is in more detail. I can move to the pages now. And if I can zoom in on certain areas here, you can see that basically we're covering all the quality assurance and submittals. Okay, we can include the actual specification itself from the 08800 glazing. Okay. And moving on to the next page. I'll zoom in again, and here you can see the standards, international standards that we're referring to, depending on what project is specified, whether it's specified in ASTM standard or it's specified in EN standard. Okay, so the standards are written into the document. Also, the optical distortion limits. Okay, you can see that the maximum peak to valley and center king is all actually mentioned in this document. Now, this is all the this is how we intend to reduce and minimize optical distortion for the glass once it reaches site. As you can see there again, that measured glass lights for optical distortion using Osprey version 7. So this is the online scanners. Okay, these reports will be maintained by the glass processor for any request by anybody throughout the supply chain, and in particular through Guardian Glass Technical Services. The last page, obviously, this just basically covers the IGMA sealant uniformity. So obviously, part of the Elite Fabricator as well is that the heat treated glass and the IGU are tested by an independent laboratory for the performance. Obviously, for the heat treated glass for tempered or heat strengthened, laminated, and for the unit double glaze unit performance as well. We're covering the anisotropy here as well, and also the color variation as well. So anything between the maximum delta E of 3. Okay. Now moving on to architects. Obviously, we have our architectural design managers who will start at the design stage of a project. They will work with the architects along with our marketing team and our technical services team and commercial team. We will work with the architects to identify projects that we feel will meet the SOQ specification. So working along with the architects, we can present to these these documents and the Elite Fabricator program. If the architect wishes to incorporate this SOQ specification into his design document, then we will announce that the project is awarded SOQ specification. And once the design documents are released, then this will be including a list of all Elite Fabricator processes and the detailed description of the quality SOQ specification. So as it passes through the supply chain, this will be visible to everybody within that supply chain. The architect also has this welcome brochure, which we can present to the architects on introducing the program as well. Moving on to technical services. Our technical services, in order to support the program and support the architects and the contractors and consultants, we have a wide range of calculations available. So from performance modeling, project proposals, structural analysis, thermal stress analysis, and so on. We have the capability of running static calculations that can easily calculate the balustrades, the canopies, curtain walls, doors, floors, the roof glazing and skylines, and so on. We actually issue a very detailed report upon request for any part of the supply chain, from architects all the way down to the aluminium fabricator. All we require is a detailed list of requirements for us to be able to calculate this, to be able to run this calculation and submit the report. We also have our Guardian Building Energy Reports. This is available on our glass analytics tool, which is on the web page. Anybody can request access to this program. This is basically where we can work again on giving you a variation of different products, and then being able to calculate how much energy consumption, how much the repayment period on the glass itself for the project, and so on. It's quite a very detailed report. All we need basically is the information for the project, the location, how many floors, the width and length of the floors, window to wall ratios, etc., etc. This is a very detailed report, and certainly helps in you as the architect or the consultant decide on the right glass for your project. We can also do acoustic calculations again. This is also available on our glass analytics tool. We have over 7 million different combinations of glass combinations that we can present to meet the required sound reduction for the project. Okay, so again, we just basically need some very simple information to be able to input this, and then obviously generate a very nice report at the end. Thermal stress. Again, thermal stress is becoming quite popular in this region, in particular to heat strengthened glass, and where we have spandrel glass in ceramic fric glass in spandrel areas. It's always worth considering that when you're looking at areas of high energy absorption, that we run a thermal stress analysis. Usually for tempered glass, this is not the case, but for heat strengthened, especially in a ceramic spandrel area, then we request that we run this thermal stress analysis. Okay, and here's just a simple report that we can generate, which gives you all the full details of the reports as well. And then we have 2D and 3D state heat transfer calculations. This is a new program that's added to our portfolio of calculations. This has the capability of generating thermal bridge analysis, heat loss calculations, basically for all the materials that's going to be used on the project. So we can take into consideration the aluminium, the spacer bar, the glass, the gaskets, everything to run a full and thorough calculation of the effect of solar energy on that section of the facade at any time of the day. Okay, we also have as well available that we can now run condensation analysis for this region, as we see that condensation analysis is becoming more apparent in this region as well. So that's also available. And then we have the transient heat transfer calculations. Again, we can actually analyze building elements exposed to fire with using Eurocodes, transient analysis for thermal bridges, dynamic thermal analysis of floor heating, and usually especially for passive solar building design. So we can support you in your design of the project in ensuring that you have the right materials and that you are minimizing the amount of solar energy emitting through those materials as well. Okay, this is a very detailed report, very complicated, and is very time consuming. So if you do ever wish to go down and work with us along with these, then a lot of information will be passed between yourselves and our technical team. So basically, just to recap, obviously we've talked about the 3-tier Select Fabricator program and how It's designed to reduce optical distortion for the glass on the project. The advantages to the elite tier as a client, as an architect, or as a consultant or a contractor, we can support basically on ensuring that the vision of the architect, the aesthetics of the projects is maintained by minimizing the optical distortion to a very tight program. Optical quality manufacturing process again, and the select optical quality SOQ document, which I mentioned earlier, and also the technical services. So before I move on to the questions and answers, I just want to go back to the first slide, which was the Maria Concert Hall. The elite program is a classic example on how we together as a team can support you in achieving the highest level of quality. The Maria Concert Hall, when we first was introduced to the project, was a challenge. It was a challenge for us. It was something we've never done in the past, and we took on the architect's vision of producing this. Of his vision of having this project in the middle of the Arabian desert. Our team worked extensively well to develop a product that would meet the environmental conditions of this region. Basically, we took our ultramirror and we developed that to be able to support the projects and the architect's vision for this project. And as today, the project stands alone in the desert, reflecting all the surrounding environment, and is recognized worldwide for its beauty and its application. So, other than that, I would like to take some time now to answer any questions if available.
Oh, sorry, I was muted. Thank you so much, Gary. That was a really nice presentation. We have some really nice questions, actually. But I'd like to start with an anonymous one from what seems to be an aluminium fabricator. So he asks, is this webinar only for glass processors? As an aluminium fabricator, he's curious.
No, I mean, this webinar is basically for everybody throughout the site, the supply chain. We have a program where we can meet with the processors or the aluminium fabricators and talk more in detail about the program itself. We are here to support each stage of the supply chain. Okay, so from architects all the way down to the glass processor, this is what this new program is designed for.
All right, Gary, thank you. So then we get to the more scientific questions. So Ahmed Nada asks, do you have a list of heat treatment or brands of machines certified by Guardian?
We don't actually certify brands. Okay, what we do is we certify the process. Okay, we can advise on which type of machine that they wish to purchase. Now there are different machines available here. You have the radiant anesthetic convection, combination furnaces, and all the way up to forced convection. Obviously, the forced convection is the top end of the heat treatment furnaces, and tend to give the best optical quality as well. So we can advise based on their requirements on which machine would probably be more suitable for them.
Thank you, Gary. Ahmed Nada also asks, what do you think about the future of TPS IG systems?
TPS is a system that's around for quite a long time now. Personally, I don't have any experience of it myself, but basically it eliminates the spacer bar, and it's more efficient in producing the double glazed units. Obviously, reducing it helps reduce the U values as well, so it has its advantages. Okay, so personally, I don't have any experience on this, but I'm aware of the product.
Thank you, Gary. Again, moving on, an anonymous person asked, how can we avoid testing HST other than heat strengthened glass in order to reduce the cost, knowing the defects can be the other thing?
Well, usually when heat soak testing is a requirement, that is written into obviously design documents, which I talked about earlier. Now, because we see a more apparent move towards heat soak testing, and that is why we've actually included it into our Elite Fabricator program. For me, it's just basically communication between the contractor, obviously, or the consultant, whether it's possible that you can remove the need for heat soak testing. In my experience, usually if it's written into the document, it's very difficult to remove, and it becomes a requirement.
Thank you, Gary. Also, the same user asks, do you have calculations based on NFRC 100 and 200?
Yes, we do. I mean, if you're talking about glass performance, then yes, we do. Our standard configurator, our performance data calculator, the default setting is NFRC. NFRC is more apparent in this region, and it's more apparent than the EN standard. So basically, as a default, we normally calculate our performance based on NFRC.
Thanks, Gary. A really nice one here. What is the reason to cause anisotropy? Can you explain a bit about this, please?
Yes, I mean, I can talk all day about this, but basically, to cut a long story short, as the glass is heated up in the furnace, you're talking around 730 degrees centigrade, the glass surface temperature and body temperature, before it moves into the quench section. At the point it moves into the quench section, there is a slowdown of the glass as it comes to a stop, and then before it oscillates back into the reverse direction. What happens is that during this period, the stresses, because the pressure on the glass from the quench blowers is at a stronger point. So you do get the high points and the low points on stresses within the glass. Okay, and usually when you see in polarized light, or if you observe with polarized glasses, looking at an angle of the glass, you can see what's commonly known as leopard spots. And it's the leopard spots that have the higher intensity of stress within that glass. Obviously, it comes through as looking like a bluish, cloudyish effect, but scattered like leopard spots across the glass surface. It's unavoidable, and it's not classified as a fault within the glass. It's an acceptable part of heat strengthening and tempered glass.
Yes, it's a very interesting topic there. Thank you, Gary. Another question here is, what is your advice of FRG? Which is better, the chemical or the thermal process?
Can
FRG.
you repeat that question? FRG. Sorry, I don't understand that question. Are they talking about the tempering?
It's a good question. We'll allow the person to perhaps write a bit more.
Yeah, we can come back to that question.
We could come back to that, yeah. Okay, then. Another question here is about heat soak testing. They say it increases the risk of breakage. How far is this true or false?
Actually, heat soak testing reduces the risk of breakage. What's basically the system is designed to do is that it will you will position tempered glass into the oven, and it will be taken up to a temperature of around 260 degrees centigrade, plus or minus 10 degrees. What this is designed to do is that for any inclusion, and I will refer to nickel sulfide inclusion, is to accelerate the expansion of the nickel sulfide, and thus breaks the glass inside the ESOQ test oven. One thing to point out is that ESOQ testing is not 100% effective. Okay, it only reduces the risk. So even after the glass has been ESOQ tested, there is always a possibility that glass may break after ESOQ testing, because it's not guaranteed to remove all the inclusions from the batch.
Thank you, Gary. Another question here from Ahmed Shamlawi. What is the minimum size for glass to be a roller wave tested?
Minimum size is a good question. I would put the minimum size at the test size of the standard, which I believe is 1100 by 365. I think it is. So I would always follow the minimum size which is stipulated in the EN standard. So 1100 by 365. Off the top of my head, I think it's 365.
Okay, Gary. We come back to Ahmed Nada's question. So by FRG, he meant fire-rated glass. So,
okay. Unfortunately, I don't have much experience on fire-rated, so I can't really comment on that. I can take some advice and information later after this discussion, and then maybe I can come back to Ahmed.
Okay, well, we have our link that you can follow. It's a landing page with a form. You can fill the form. It's very easy to fill. With a quick message, we'll be happy to answer you, or take this discussion forward offline, because some topics need a little bit more, perhaps, delving into. So another question here. Project specifications need all tempered glass to be HOQ tested. Is this recommended?
To be?
Heat soak tested.
ESOQ tested. If I understand the question right, I mean, not all tempered glass is required. Only to be ESOQ tested. Only if the project specifies that the glass must be ESOQ tested. If the project specifies the glass ESOQ tested, then 100% of the glass should be tested. Is that the answer to the question?
We'll find out. If Ravi, you would like to know more about this, please follow the link, fill up the form. We'll be very happy to continue this conversation offline. We have another one, Gary, here from Mr. Firoz Kanchwala from Future Glass. Can a developer, architect, not and architect, can a developer or architect be confident of getting the best quality when choosing a select elite fabricator? And how does Guardian support such a project during the execution stage?
Yeah, it's a good point from Firoz. Basically, part of the elite fabricator program is that once a project is recommended or has achieved the select optical quality, and the glass is delivered to the processor's facility, we as Guardian technical team will be on site for the duration of the project to ensure that the glass at each stage of production meets the requirement of the SOQ specification. Okay, so basically, in answer to Firoz's question is yes, we will be there to ensure that at all stages of production, the glass will meet that specification.
Thanks, Gary. A more scientific question here. So what initiatives has Guardian Glass taken to minimize NIS inclusions in your float glass? I believe that means nickel sulfide. And how Guardian Glass can support its clients in case of large volumes of nickel sulfide related breakages?
Yeah, it's a good question. As with all our Guardian plants, we have a number of processes in place that to minimize the risk of nickel sulfide. Unfortunately, it's not possible to totally eliminate this, and it can be always there. We have quite a thorough program positioned at each plant to minimize this, and basically that's all I can say on this at the moment.
Okay, thanks, Gary. A related question here. Spontaneous breakage happens, as we theoretically know, for many reasons. Nickel sulfide or extra stresses near the edge are examples. So what are Guardian Glass's statistics on the existence inclusions and their float, if we have? Also, how involved as Guardian support teams are on this subject when Guardian does not warrant glass breakage on site?
There is basically no. There are statistics available out on the web where investigations have taken place on spontaneous breakage on certain projects. There is only one standard available which covers the nickel sulfide breakage, especially, and that's the HESOC test standard, where that stipulates 1 in every 400 ton of HESOC tested glass. Okay. What Guardian do is that, as we don't warrant breakage, we have a program where we can talk about the causes of spontaneous breakage, and we have a white paper of this available, which we can send, which it explains in detail the effects of spontaneous breakage and so on. I hope that it's a difficult question, but I hope that answers the question.
All right, thanks, Gary. So we have another one here from Nidal Habash. Is there any difference in color when using the same coating on different clear glass thicknesses?
There are very slight color differences, but it's not noticeable to the naked eye. We have the capability of giving you the color coordinates of the 6mm with a coating on, as opposed to 8 and 10 and 12. We can compare that for you and present that to you. So that's something that we can offer as well.
Great. And if you'd like us to offer it, please get in touch with us with the link and with more details, and we'll be happy to help you. Another one here, Gary, is about safety glass for outer light in the tall building, I believe, which is not required in this region. To use the HS glass for outer light, if it breaks, based on your experience, will the glass hold by the structural sealant and not fall?
Yes, the heat strengthened glass is designed that when the glass breaks, it breaks to the edges of the glass and is held in place by the silicone bead. Okay. Now, if you refer to the standard for HESOC testing, for the heat strengthened glass, which is the EN 1863, you will see that even in the break pattern on there, you're allowed 2 islands to a particular weight, okay, or size. Okay, so in answer to that question, I would always refer to the heat strengthened standard before you decide to go for heat strengthened on the outer panel. You also need to consider safe if there's areas where safety is a requirement. So if safety is a requirement, then you need to go to fully tempered glass.
Okay, thank you, Gary. Another question from Firoz Kanchwala. We've had prestigious projects wherein wherein clients have asked for an independent consultant to inspect the panels before loading. Can Guardian in-plant support in this regard be considered as an independent quality review?
Yeah, I mean, I think I actually discussed this before, so it's something that we can support and advise on, definitely, yes.
Very good. Well, on this note, we have a minute left to the webinar, and we don't see any more questions coming in. At least ones that we always would like you to get in touch with us, because it is a bigger discussion, and we'd like to help you more with than just a brief answer here. So thank you everyone for this, for your time, for the great questions. Oh, there's one more here, since we have time, before I thank you all. And I think it's important. So Guardian EPD, Environmental Product Declaration, in other words, provides a good documented answer for Guardian lead involvement as a manufacturer. Aside from the materials and resources side, can the glass fabricator be more involved in achieving more lead credits? Gary or Maher, would you like to answer that?
I think I can answer this one. Usually it's the project that is is where it's earning the lead points. Now, obviously, the location of the glass processor or the location of the glass manufacturer has an impact on how many lead points are achieved. Okay, so obviously it's got because of the distance. So it's always worth inquiring. We can definitely support on the lead document. Obviously, we have our capability support on this, and we can give the best advice on that as well.
Thank you, Gary. I'm going to take another minute here because we have a really nice question from Nidal Habashagan. As glass specs, we have to consider first the shading coefficient or the U-value, knowing that we are in the hot area.
Actually, it's a good question, Nidal. They are the two most important factors of reducing solar energy and obviously heat transfer. So they basically work along together.
Okay then. Thank you so much, Gary, and thank you everyone for your time. Again, this webinar will be live for your viewing pleasure after this. You'll be notified by email. And yes, we look forward to keep answering your question. We are here to support you all the way as your local glass expert. You can count on us. Thank you so much for your time, and you'll see this soon on YouTube. Have a great day ahead from everyone.
Thank you, everybody.
At Guardian.
Thank you, everyone.